In our next section for the content-based access control and the zone-based policy firewall, we're going to talk about the port to application mapping, or PAM feature, that is used to control what are the port numbers that we are matching when we issue either the match protocol command in zone-based policy firewall or the IP inspect command followed by the individual application match. Now, by default, both the content-based access control and the zone-based policy firewall are going to use the well-known port numbers that are assigned to a particular application for that individual traffic matching. Now, for example, when we're talking about web browsing, if we were to say match protocol HTTP in the case of the zone-based policy firewall, or the IP inspect command HTTP for content-based access control, it means that we are looking at TCP port 80. Now, we can verify what are the default port numbers that we're using for the port to application mapping if we look at the show IP port map command on the command line interface. Now, one important point to note about this, we want to look at the show IP port map command, not the show IP nbar port map command, where the nbar variation is going to be for port mappings related to quality of service that are matched in the MQC syntax of the match protocol, where the regular IP port map is going to be for the CBAC and for the zone-based firewall. Now, in addition to matching on the standard port values, when we say match protocol telnet, we know it's going to match port 23. In the case of match protocol HTTP, like I said, we're going to be matching port 80. But we can alternately change these if there's some particular service that we have running on a non-standard port. For example, if we have a web server that's running on TCP port 8080, we could define a custom port mapping that says when we're matching the protocol HTTP, not to only look at the default of 8080, or excuse me, the default of 80, but we could also look at 8080. Now, the reason that you would want to do this is that if you are inspecting traffic with either CBAC or the zone-based firewall, but we don't want to set up a complex set of access lists to poke individual holes in the firewall, we can still use the inspection engine, but allow it to run on non-standard port values. Now, it also support this on a per host basis or a per address range basis. So we could say that we have a number of web servers inside the network, but only server A runs on the non-standard port of 8080, and the rest of them run on the normal port 80. And we could do this by matching an access list along with the IP port map command. Now, this would also allow us to have the same port number that is used for different protocols on different hosts, where maybe one web server is listening on 8080, but then a different FTP server is listening on 8080 for the FTP service. And based on the particular access list that we're matching with the nbar port map, we are able to assign the same port number to multiple protocols because we're doing it on a different host basis. Now, if we take a look at the command line, and as I mentioned here, the command we're looking at is going to be the show IP port map, where these particular port mappings, again, are going to be just for the security features with either content-based access control, which is the IP inspect command, or the zone-based policy firewall, which is using the match protocol command under the class map type inspect. Now, we can also use this to figure out for other applications in the network what are some of the default protocol numbers and the port numbers. For example, here it says we have a mapping for the bootp client, which is UDP port 68. This is our DHCP request from a client, where we would also see one here that is the bootps for the bootp server, which is going to be the response or the offer from the server down to the client. Where we see the GDOI, this is the multi-point keying that is used for the get VPN feature, which uses UDP port 848, we can see. Then you'll also see some other application level things like Skinny or H323. This is going to be for different media and voice applications. And if we go down towards the bottom, eventually we'll see where it says that the web traffic for HTTP is listening at just default port 80. Now you'll also see that some of these are using ranges of addresses and multiple protocols, where in the case of AOL it says it's TCP 5190 to 5192, but it's also UDP 5190 and through 5192. So not only is this a range of addresses, but it's matching on the two different IP protocol numbers, which are both TCP and UDP in this case. Now we could sort through this if we said show IP port map pipe include or pipe exclude, and then list the particular value we're looking for. If we said show IP port map and then include HTTP, we see we have separate matches for regular clear text web browsing, and then for SSL based HTTPS, where we're using TCP port 80 and 443 by default. Now if we were to compare this to the show IP nbar port map, these are two separate configurations. Now we'll see a lot of these values are going to match the same by default. We'll see in here that HTTP is matching port 80 automatically. But the key point is that if we were to change the nbar port mapping, which is for the quality of service applications, it is not going to affect the security filtering of either the IP inspect engine with CBAC or the CBAC engine as it is called from the zone-based policy firewall. So just be aware of this. When we say show IP nbar port map, that's for QoS. When we say just regular show IP port map, that's for security. That's what we want to look at here. So let's take a look at our topology, and let's test this out, where again on router 3, we have the zone-based policy firewall configured, where we have the inside zone attached to the connection to router 4. We have the outside zone that is connected from 3 to 2. And I'm going to be testing this from the Windows PC that's located here down on VLAN 118. So the first thing I'm going to do is configure router 4 to run the web service. We'll turn the HTTP server on at regular port 80. And on the zone pairing that I have from the outside to the inside on router 3, I'm going to tell it to inspect HTTP traffic, which means that the test PC should be able to initiate the web session to router 4 and then get the response back in. Because again, when we are inspecting the traffic from one zone to another, it means that the return traffic will automatically be allowed, assuming that the session is actually active. So unlike the ASA here, we don't have security level numbers that are associated with the interfaces. So there's no technically inside-outside interfaces. It's really just how we define it with the zone pairings. And this is one of the advantages of this configuration versus the CBAC or versus the ASA, that it's much more flexible as to how we associate the policies with the zones decoupled from the actual physical interfaces. So next, let's go to router 3 and look at its current configuration for the policies. And again, if we look at the show zone security, it says we have 3 different zones that are inside, outside, and DMZ, in addition to our system zone that is the self zone. If we look at the show zone pair security, we have a pairing for traffic going from the inside to the outside, from inside to the DMZ, from outside to the DMZ, and from outside to inside. Now, since in this particular case, the web server that we're using, which is router 4, is located on the inside of the network, I want to apply the inspection as we're going from the outside to the inside, where this is the source zone outside, the destination zone inside, and the particular policy it's using is the outside to inside policy. So again, based on the fact that I'm trying to make these class names and the policy names, the zones and the zone pairings very descriptive, it makes it a little bit easier when we're trying to decode the configuration as to actually what direction of a filter are we trying to apply. So now I know if we look at the show run section outside to inside policy, this is what I would need to modify in order to get traffic that is web traffic from the outside to go in, and then for the sessions to return. Now, I already have this class that is the outside to inside exceptions that is being passed. I could technically modify this so that I was also matching the web traffic going to router 4. But the problem with this, since I'm saying pass instead of inspect, it means that I would have to pass the traffic in both directions. So what I'm going to do here instead is create a new class that is going to match the web traffic going to router 4, and then we will inspect that as we're going outside in. Now, I could be very specific. I could call an access list that's matching router 4's address and call the protocol from inside the class. It really just depends on how granular we want to be with the policy. So in this case, I'll simply say in the class map type inspect, we'll say that this is the outside to inside inspect class. Where the other one was the exceptions, this is the one that we're actually doing the inspections on. Now, just in case I want to add multiple matches later, I may want to change this so that it says to match any as opposed to match all, which is the default. So again, in our particular case, I want to match the protocol HTTP. So that's going to be for any web traffic that's going from the outside to the inside. Then I need to call this from the policy map, which is the policy map type inspect outside to inside policy. For the class I created, outside to inside inspect class, I am going to inspect this traffic. So no additional parameters onto it, nothing special about this. We don't need to specify what is the particular host address. We don't need to specify the port number, because by default, when we look at the show IP port map and include HTTP, we are going to be using port 80 automatically for this traffic. So next thing I'm going to do is go to router 4 and actually turn the web service on. In global config, we'll simply say IP HTTP server. And this is going to be running at the standard port 80 by default. So now if we were to go to the test PC, that again is located down here on VLAN 18, we should ideally be able to send our web browsing session to router 4 and then get the response back in. Where in this case, router 4's address is 172.16.34.4. We see the login box pop up, which means that we did establish the basic TCP session. And now we can see we have the connection to router 4 for management. So if we were to look at different commands like the show log output, we could see that we do have a proper web connection to router 4. Now, additionally, if we were to go to router 3 and look at the show policy map, or excuse me, the show service policy. Actually, I was correct. Show policy map type inspect zone pair sessions. We should see from the outside to inside that we're going to have inside the inspect class that we're going to have an active session. Now, we would actually need to look at this right as we're doing the web browsing. So let's say show policy map type inspect zone pair outside to inside sessions as we run one of these commands. So let's go home and then run show tech support, for example. Once we do this, we should see that the session from router 4 back to the Windows machine, which in this case is the 192.168.118.110 address, we can see that the TCP connection is open. So nothing really special here. If we look at the show run section, class map or policy map or zone, we see we have the outside to inside inspect class, which says match HTTP. We then have the outside to inside policy, which says for the inspect class, we're going to inspect that traffic. Then this policy is called from the zone pairing, which is the outside to inside pairing, which then calls the policy. So again, it's a lot of syntax to piece together, but the overall logic simply means that for any web traffic coming from the outside to the inside, we're going to inspect it. Now, since both the web client and the web server are requesting this session on port 80, we don't need to change anything that's related to the port to application mapping. Now, the case where we would need to do this is if we were to change what is the port number that the server is actually listening on. So if I were to say on router 4 that the IP HTTP port number is some non-standard value, let's say 65080, this would then mean from the Windows client, I would only be able to get to router 4's web interface if I were to say use port 65080. And if we now look at router 3, we have a log message that says traffic was coming from the outside going inside, but this was matched by class default, which is dropping the traffic. So even though this is still a web browsing session, the problem is the router is not looking at port 65080 to associate it with this match protocol HTTP that we have here under the outside to inside inspect class. So this is what our port to application mapping would be used for. If I were now to say on router 3 that there's an IP port mapping specifically for HTTP that is port TCP 65080, and we can see we can match multiple port numbers, or you can match a range of addresses. But now I'm telling it to listen at 65080 instead of just normal 80. If we look at the show IP port map and include HTTP, we can see that we're still using the default value of 80 because this one is system defined, but we're additionally having a user defined value of 65,080. Now, what we should see in the change here is that when the client goes to browse to this address, we don't need to add an additional exception, either with an access list or another class with a pass entry, because now when router 3 is looking at the inspect HTTP, it's looking for port 80 in addition to this 65,080. And if we look at those sessions again, the show policy map type inspect, zone pair, the name, sessions, we should see once we actually send the traffic, there should now be a session from the Windows client to the server, but now the server is running at port 65,080. Now again, in addition to these normal changes with the port numbers, which we're doing here with the IP port map command, we could also change this on a per host basis. Whereas if I had one server on the inside that was running a custom port, but the other ones were running the standard port values, I may want to change this on just an individual host or an individual segment basis. So now let's say, for example, that in our particular topology, that we're going to change router 3's mapping for the web traffic, but only for hosts that are on this particular VLAN 4 segment, which is the 172.16.4.0/24 address or range. So in addition to using the IP port map command on router 3, we're going to use an access list that says to change the port value, but I also want to change it just for this specific range of hosts. And we'll see the advantage of doing this way is that we do not need a manual access list applied to the interface, and we don't need to change the rest of the zone-based policy firewall configuration. Anytime we're saying match protocol HTTP with zone-based firewall or with CBAC saying IP inspect HTTP, it's going to look not only at the port number, but also the access list to figure out, is this going to a host that we have changed the custom port mapping for? So next on router 4, what I'm going to do is change the port number again. We'll change it to some other value. Let's say 30,080. where now router 3 is going to configure an access list that says access list 4 permit 172.16.4.0 with a wildcard mask of 000.255. So this is going to match any host that starts with the address 172.16.4. Now when we change our port mapping, the syntax is going to be similar as before. IP port map HTTP, we're using a TCP port. We're changing this to 30,080. But now we're doing it just for addresses that are matched in access list 4. Again, if we look at the show policy map type inspect for the zone pair sessions for the outside to inside pairing, we want to look at what are the number of packets in the class default and what are the number of packets that are in the outside to the inside inspect class, where this is where we're actually matching the HTTP protocol. We could see right now the number of packets that had been inspected were 8. The number of default packets that were dropped were 3. Now, if I were to go back to the Windows host and change the port number here to 30,080, if we look at router 3, it says this session is being dropped from the Windows host going to 172.16.34.4 at 30,080 because the zone pairing outside to inside is using class default to match this flow, and class default says that we need to drop the packets. So if we look at the zone pairing sessions, we should see that the class default was incrementing, where this was previously 3 packets, now it's 6. So even though the end host is using the correct port value, it's not using the correct address. If we look at the show IP port map and include HTTP, it says there's multiple mappings for HTTP. The 30,080 mapping is host specific, where not only does it have to be this particular port number, but it has to be for a host that is matched in access list 4. Where again, access list 4 here is someone in the 172.16.4 network. So now on the Windows client, if we were to take this same URL but change it from the 34.4, which was the outside interface of router 4, and we change it to this inside interface that is matched by the port to application mapping, we now see the traffic is allowed. And if we look at the show zone pair sessions, once we run a command, we should see that router 3 is correctly classifying this. So it's traffic coming from the Windows host, going to router 4 on the inside, and going to port 30,080. Now this would again also allow you to have some other protocol that is overlapping the port number of 30,080 as long as it was going to a different host address. So for example, I could say that on router 4, or excuse me, on router 3, that I have an IP port map for telnet. And the telnet port was TCP 30080. But if this was going to a different host on the inside, then this is going to be valid because the classification with the CBAC engine is looking at not only the protocol number, so is it TCP? Yes. Is it port 30,080? Yes. But is it also matching this particular access list for where the traffic is going to? Now, the other way that we could do this is by defining a custom port to application mapping, which is defined as a custom protocol. Specifically, the configuration for this is when we issue the IP port map command, it's followed by the keyword user dash, then any string that we can define. So we would say, for example, IP port map user dash custom protocol 1. This is going to work similar to changing the port mapping for a protocol that already exists. However, if it's some non-standard custom application, it may make it easier for us to just define a new value for then to be referenced in CBAC as the IP inspect command followed by the protocol user dash and then the string. Or in the case of the zone-based policy firewall, inside of our class map type inspect, we would say match protocol user dash and then whatever our custom string is. So let's take a look at this in our same particular case here, where we have router 4 as the server, the TCP server that is listening for sessions coming from this Windows machine. Now, we already saw it listening on the web service at port 30,080. And I'm additionally going to configure router 4 to listen for telnet packets that are going to port 3,100. And the way that I can do this is with the rotary command under the VTY line, where typically the router is going to listen at normal port 23 for telnet. But if I were to go under line VTY and issue the rotary command, whatever number I add here, so I'll say 100, the router is now going to start listening at 3,000 plus the rotary number, 5,000, 7,000, and 10,000 plus the rotary number. So from router 4, if I were to telnet to my own address here, but telnet at port 3100, we should see that it's listening for the telnet service there, which it is. Now, it does, like I said, additionally listen for some other port values here, but there's a little bit difference as to how the protocol works. So you can see when I was issuing the username there, it's echoing multiple characters back to me, where for the telnet port, you would want to use 3,000 plus the rotary number. These other port numbers are for some other different applications that we could use. So now what I want to do on router 3 is to configure a custom protocol definition that says to look at TCP port 3100. Then we could use this inside of our zone-based policy firewall to say match protocol, whatever the custom name we're using, then it should inspect the traffic going to port 3100. So our first step on router 3, we'll say IP port map. And if we look at the context-sensitive help here, it says you can have a user-defined application name, but use the prefix user dash. So if we start with IP port map, user dash, give it a name, we'll say custom protocol 1. And just like the other configurations, it's going to ask you, is this for TCP? Is this for UDP? Is it for both? And what is the particular port number? Or in this case, I'll say TCP port 3100. It says, unable to add the port map entry, the application name is too long. So let's say user dash custom 1. Okay, so next if we look at the show run section class map, I already have my class map type inspect that is for the outside to the inside. And since this is a logical OR match with the match any, I could simply take this same previous class and add a new match protocol. But we should be able to see now that we're going to have the option for the custom protocol, which is user custom 1. So if we say match protocol user custom 1, we can see now it's in the context sensitive help. If we now look at the show policy map type inspect, the zone pair's name is outside to inside, and the sessions we should see for the outside to inside inspect class, we're now also doing the inspection for the protocol named user-custom 1. So if we were now to go to the Windows server and telnet to router 4's address, we would see that the normal port 23 traffic is going to be dropped by router 3, It says port 23 going to 172.16.4.4 is dropped on the zone pairing outside to inside. But if we were to change this to go to port 3100, we can see now the connection is successful. And if we look at the zone pairing sessions again, we should now see that for that particular custom one, we do have the session coming from the Windows server, going to router 4, but it's going to that particular custom value. So again, this particular application would be used if you want to allow custom port numbers through the firewall, but you do not want to use the pass action. Because remember, with the pass action, that is a unidirectional pass, where I would have to pass it from outside to in, then from inside back to out. Now, additionally, when we talk about some of the advanced application level inspections and the advanced customizations you can do with the zone-based policy firewall, not only can I do the inspection based on this custom port number, I can still use the TCP normalization engine of CBAC in order to do things like protecting this particular server against a TCP SYN attack or against any sort of non-standard TCP option type of attack. Where if I were to do just the pass option, I would not have those particular features available to me.